Hey everybody, we're back and we're in the last ed puzzle of the year. Awesome. So we talked about graphs of sine and cosine. Now we're just talking about the graph of tangent and some trigonometric identities. So I want you to remember a couple of things. Remember this cute little chart over here for common angles. Remember we talked about sine and cosine are as easy as 1, 2, 3, 3, 2, 1, all over 2 with roots on top. And then remember, tangent was sine over cosine, and that's how we got root 3 over 3, 1, and root of 3. In addition to that, remember that we just were talking about yesterday, that cosine comma sine in the unit circle is the cosine of 0 is 1. The cosine of 90 is 0. The cosine of 180 is -1. And the cosine of 270 is 0. And coming back to 360, it's 1 again. And then the sine of the angles is sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. And sine of 270 is -1, and then back at 360, it's 0 again. So we're going to use these in conjunction to talk about, remember that that tangent is sine divided by cosine. So at tangent of 0, that's like saying the sine of 0 degrees over the cosine of 0 degrees. So if I look at that, I know the sine of 0 is 0. And the cosine of 0 is 1, which that's 0 divided by 1 is just 0, and that's fine. Now, if we look over here, tangent of 90 is really the sine of 90 over the cosine of 90. So that tells me that the sine of 90 is 1, and the cosine of 90 is 0. Well, remember, we've got chaos, we've got markers flying, we've got black holes. This is an undefined value because we cannot divide by 0. Let's look at tangent of 180. We know tangent of 180 is really sine 180 over cosine of 180. So we know here sine of 180 is 0 over cosine of 180 is -1. Well, 0 divided by -1 is still 0. And if we look here at tangent of 270, we know tangent of 270 is sine of 270 over cosine of 270, which that is sine is -1 all over cosine is 0. Again, we're undefined. And then we know how the last one's going to go. We know tangent 360 is really sine 360 over cosine 360, which is 0 over 1, which is, again, 0. So here's the deal. Then we know, if I were to graph this, that the tangent function looks like this. Well, no, tangent of 0 is 0. So at 0, we plot it right here. But at 90 degrees, it's undefined. So we have what's called an asymptote, where it's undefined. Tangent at 180 is 0 again. Tangent at 270 is another asymptote because it's undefined. And then tangent of 360 is 0. Well, we don't know what to do with that. So let's look over here at these values here. So remember at 30 degrees, it was root 3 over 3. That's a positive value. So this is about 30 degrees right here. So it's about like this. At 45 degrees, which is about halfway, it's a value of 1. I'm going to make this one a little bit lower, sorry. And then at 60 degrees, it's a value of root 3 over 3, which is about like this. So when I plot these, it goes like this, and it kind of goes up like that, follows the asymptote. And so we can see here, every pattern from the 0, we go up and to the right like this. And if we were to go negative, it would be the exact opposite, like this. And this is our tangent function. So for tangent, the period, instead of being 2 pi like sine or cosine, we see the period here is actually from let's say one increment is 90 to 270 degrees. That's a total of 180 degrees, or you can call that pi. So it has a different period than sine and cosine, and the amplitude is infinite because it keeps going. But it does have this interesting thing. It has these asymptotes every 180 degrees as well. Basically, wherever sine, or I should say, wherever cosine was 0. Okay, so there's our trig functions, or there's our tangent function. Go ahead and copy that down. So every trig function can be based off of sine and cosine. This is really critical that you know that. Literally that every trig function can be based off of sine and cosine. We saw that in tangent, which tangent is sine divided by cosine. So if tangent is sine over cosine, cotangent is just the reciprocal of that, cosine over sine. So we can already see that we can take every other trig function and make it in terms of sine and cosine. We also see that in reciprocal identities. We know cosecant is 1 over sine, and that secant is 1 over cosine, and that cotangent we also know is 1 over tangent. These are called the reciprocal identities. And the last new one is the Pythagorean identity. Remember the Pythagorean theorem, which was a squared plus b squared equals c squared? This looks a lot like that, but instead of a and b and c, we use sine squared x plus cosine squared x equals 1. And that's a Pythagorean identity. So if I were to simplify the trig expression, cosine times tangent, here's what we're going to do. We're going to remember, we're going to put everything in terms of sine and cosine, because everything can be put in terms of sine and cosine. So I know cosine is already cosine, we're good, but tangent can be written as a sine over cosine. So if I were to rewrite this, do you see what's going on here? I've got cosine over 1 times sine over cosine. Well, cosine can cancel with cosine here. And so I'm left with sine over 1, which is just sine x. So that's how we simplify trig expressions. We put them in terms of sine and cosine, and then we cancel where we can and simplify. All right, guys, that's it. That's our last ed puzzle. Whoop, whoop, you did it. End of the year. See you in class.